Scientists found a gap in the universe that defies all logic. Know absolutely everything there is to know about the universe. That's the ultimate scientific dream. Scientists expect not just to understand the laws that govern reality as fully and deeply as possible, but to understand how every single particle in existence behaved from the moment of the universe's birth up through the present day. But this dream isn't necessarily one we're capable of realizing, even with arbitrarily good equipment and ideal observational methods. As vast as the universe is, the part of it that's observable to us, both now and in the future, is still finite. All of the stars, planets, and galaxies that can be seen today make up just 4% of the universe. The other 96% is made up of stuff astronomers can't see, detect, or even comprehend. So, it's understandable, as humans know surprisingly little about one of the largest features of the cosmos: big old voids of nothingness. If the universe was a brain cell, cosmic voids would be the space between the neurons. And they're absolutely huge, sometimes measuring in at hundreds of millions of light years in width. Thanks to advanced technology, scientists finally have found such a gap, and it defies all logic. A new theory even floats the possibility that these voids might explain one of the most galling mysteries in all of cosmology. The theory proposes that these cosmic voids may be the source of dark energy, the yet unexplained force that most experts believe is causing the universe to expand faster and faster. But does this hold true? What terrifying secrets are hiding in the void? The answer will be exposed in today's episode of Eyes 200M. In 1981, Robert Kirshner was working with the other astronomers at the University of Michigan to calculate the redshifts, a measure of how fast something is moving away from Earth, of a great number of galaxies. Due to the way our universe is expanding, the farther away a galaxy is, the farther it moves, meaning redshift can be used to measure distance. Kirshner and his team were taking advantage of this to create a 3D map of the universe. As the map became fleshed out, something strange appeared. At 700 million light-years from Earth, there was a blank void. In a roughly spherical region around 330 million light-years wide, a region the Milky Way could fit into billions of times over, there were barely any galaxies. Initially, the region was referred to as the Great Nothing, but later came to be known as Boötes Void, as it appears to lie in the constellation of Boötes, the herdsman who drives the plow around the North Pole. Since then, surveys have managed to create more detailed maps of our universe. At the very largest scales, zooming out from solar systems, stellar clusters, and even galaxies, a surprising pattern emerges in nature. When you zoom out far enough that entire galaxies, each one home to hundreds of billions of stars, are just single dots of light, we see an amazing structure emerge. Galaxies in our universe are not scattered about randomly like salt spilled on a table. Instead, they form the largest pattern found in nature. We see dense clusters, home to thousands of galaxies, and long, thin strands connecting those clusters. These strands act like long highways stretching between the clusters, with thousands of galaxies strung along them. And we see those strands bound together to form broad, immense walls. We call this immensity the cosmic web. It's made of galaxies in much the same way as your body is made of microscopic cells. But the metaphor can only go so far. To make a proper scale model of the cosmic web, your cells would have to be 1,000,000 times smaller than they are. But while the light of the stars and galaxies of the cosmic web stand out, those structures only serve to set the boundaries of the true masters of the cosmos, the empty regions between them. It was a cosmic accident, a blight in the universe, A Sahara too vast to describe except with the reducing, almost meaningless jargon of the astronomer, an empty patch devoid of galaxies almost 20 megaparsecs or 65 million light-years across. First discovered in the early 1980s, these cosmic voids dominate the volume of the universe. In other words, most of our universe is completely, totally empty. If you search hard enough, you can find small, dim, dwarf galaxies scattered inside the voids. And of course, there's the ever-present thin soup of radiation and particles that flood the cosmos. But the voids are well and truly empty, deserted of any meaningful structure or concentration of matter. The seeds of the voids were planted in the earliest moments of the universe, before even the first stars and galaxies appeared. Billions of years ago, the matter in our universe was almost perfectly uniform, with no variations from place to place. But there were tiny, random, microscopic differences, just a millionth more matter over here or a millionth less matter over there. As our universe aged, these differences grew. Gravity is an incredibly weak force, but it's very persistent and extremely patient. The regions of our universe with ever so slightly an advantage in matter also had a slightly stronger gravitational pull. That caused more matter to be drawn toward that patch, emptying out its surroundings. As more matter accumulated, the gravitational pull grew strong, and the surroundings emptied out even more. Over the course of hundreds of millions of years, the cosmic web began to emerge, first as small clumps, which ignited as the earliest stars. Then, small galaxies appeared and merged together before forming the great clusters of galaxies, the filaments, and the walls. As the rich got richer, the poor got poorer. The void started out as small, effervescent dimples in an otherwise smooth and harmonious fabric. But as the cosmic web grew, so did the voids, all their matter rushing into the gravitational embrace of large, bright structures. Today, voids make up over 80% of the volume of the universe, yet contain less than a tenth of its total mass. Most of them are around 30 to 300 million light-years across. Bootes is one of the largest, earning it the title of supervoid. It's thought that Bootes is the product of smaller voids merging together, and that emptiness gives them a secret power. In the late 1990s, two teams of astronomers discovered that the expansion of the universe is accelerating. Our universe is getting bigger and bigger, faster and faster with every passing day. We had expected to observe the opposite. In an expanding universe, the gravitational pull of all the matter in the cosmos should gently slow down that expansion, not speed it up. Confirmed with multiple experiments in the past quarter century, the accelerating expansion has a name. We call it dark energy. Simply put, we have no idea what dark energy is, but we suspect that this mysterious acceleration is somehow a property of the vacuum of space-time itself. In other words, dark energy is built into the very fabric of the cosmos, and it's causing the expansion of the universe to accelerate everywhere. But we don't feel that acceleration locally. Earth is not expanding, the solar system is not expanding, the Milky Way is not expanding, and not even our local cosmological environment is expanding. That's because our local patch of the universe is filled with stuff. Stars, gas, dust, people. All that stuff has gravitational attraction, and it completely overwhelms the effects of dark energy acceleration. But not in voids. The voids are empty. That's their definition. There are no stars or gas or dust or people. There's nothing within the voids to counteract the effects of dark energy. And so the voids are growing, accelerating in their expansion. They are literally pushing on the filaments and walls that surround them, driving matter away from themselves in their pursuit of relentless expansion. In about 10 to 20 billion years, the cosmic web, with all its glory of galaxies, filaments, and walls, will dissolve. First, the filaments will pull themselves apart as the voids around them squeeze them out of existence. Then the walls will dissolve. The clusters will survive, but each one will become an island universe, effectively alone in a vast expanse of nothingness. Before that happens, however, we have plenty of work to do. While dark energy soaks every cubic inch of space-time, it only shows itself in the voids. So, if we want to study this mysterious force that will dictate the future of the universe, we can't look inside the galaxies or clusters. Their internal gravity is just too strong, washing away dark energy's influence. Instead, we have to look into the voids. The voids are our key to understanding dark energy. Their growth over cosmic time, their shapes, their numbers, and all their properties tell us about the strength and history of dark energy. If dark energy had a different strength or a different evolution, it would show up first in the voids. Astrophysicists have already begun to map as many cosmic voids in the universe as possible to compare their features and characteristics to our theoretical estimations. Researchers hope these wide region surveys can tease out the subtle and poorly understood properties of dark energy. But there's more. The cosmic voids are the greatest time capsules in the cosmos. In billions of years, they simply have not changed all that much. Within galaxies, stars live and die. Matter and material drift away and recombine. The galaxies look nothing like their younger selves, but billions of years ago, the voids were simple, empty. And today, billions of years later, they are still simple and empty. The answers to these cosmological mysteries, the nature of dark energy, the properties of the ancient cosmos, and more, live inside the voids. And so, perhaps, our greatest insights will only come once we stare into the abyss. In the meanwhile, a new study gave a world-shattering claim that our very own Milky Way galaxy may float near the center of one of these voids. Using data from large-scale telescope surveys that count galaxies, the researchers at the University of Wisconsin-Madison concluded that the Milky Way exists near the center of a region that has fewer galaxies than other parts of the universe. They estimated the size of this void to have a radius of about 1 billion light-years. If they're right, humans are living in the middle of the largest known void in the observable universe. The researchers first advanced this idea in 2013, but they took it a step further this week in findings presented at a meeting of the American Astronomical Society in Austin. The Milky Way's place inside a void, they said, would help explain a question in the way astronomers measure how fast the universe is expanding. The universe has been expanding ever since the Big Bang, more than 13 billion years ago, and evidence suggests its expansion rate is accelerating. There is, however, dispute about the precise rate of expansion. Some astronomers observe bright objects like Cepheid stars or supernova in the nearby cosmic neighborhood, studying their light to determine how fast they're moving away from Earth. Others peer deeper into the universe's history and study the cosmic microwave background, the radiation left over from the Big Bang that fills the universe to this day. Different measurements yield different results, and the measurements from the local universe turn out to be higher than those gleaned from the early universe. Astronomers don't know whether the discrepancies are a result of statistical fluctuations or hints of new physics we don't yet understand. If the Milky Way were in a void, the difference in results would make sense, according to Ben Hoshite, one of the University of Wisconsin-Madison's researchers who graduated from the school this past spring. If you're living inside this void, you're going to see things being pulled away from you, toward the mere dense regions of the universe, he said. So, if you're sitting in this void, your surroundings expand faster than the rest of the universe. From this vantage point, observers would calculate a higher rate of expansion compared to what they find in the distant early universe, like they do now. We should take into account our place in this very large universe, and we should be aware of how our space could potentially influence the measurements we make on Earth, Hochschild said. Previous research has suggested the Milky Way may exist in a region less dense than others, said Peter Melchior, an astrophysicist at Princeton University who studies the distribution of matter in the universe. The idea that the Milky Way might exist in a void is not unreasonable, given the abundance of voids out there. Astronomers believe the Milky Way and its neighboring galaxies reside near the local void, a region 150 million light-years across and so empty that it's pushing galaxies like ours away. But there's no way to zoom out far enough to pinpoint the galaxy's spot in the wider universe. The size of the void Hochschild and his team have proposed, though, is remarkable, Melchior said. The void is far larger than any previously observed by telescope observations, like the Sloan Digital Sky Survey, which in 2000 allowed astronomers to start investigating the large, Swiss cheese-like scale of the universe for the first time. Most voids measure between 90 million and 450 million light-years in radius. They're kind of like bubbles. They get bigger and bigger as the universe not only expands, but as more galaxies get pulled out over time, said Greg Aldering, an astrophysicist at the Lawrence Berkeley National Laboratory, who studies cosmological measurements and dark energy. But it gets harder and harder to make a really, really big void, he said. The suggestion that we might be at the center of that is a little uncomfortable too, Melchior said. It's mathematically unlikely, he explained over email, but even more so, being in the center of the largest void in the observable universe would put us at a very special place. And since the times when we learned that the Earth, or the Sun, isn't at the center of the universe, astronomers try to avoid theories that put us at special places. Eventually, astronomers hope to use such voids, shapes, and distributions to explore the nature of dark energy, the unknown force responsible for accelerating the cosmos's expansion. Last year, astronomers used data from the Sloan Digital Sky Survey to compile a catalog of cosmic voids, characterizing their sizes and densities. From observations of a quarter of the night sky, they found hundreds of voids. Scientists hope these patches of darkness can help them investigate dark energy, the invisible force accelerating the expansion of the cosmos. The effects of dark energy may be easier to detect in the darkest territories of the universe, away from the glare of stars and galaxies. The study of the cosmic voids, whether we live in them or not, serves as a reminder of how young scientists' understanding remains of humanity's place in the cosmos. I don't know how many people realize just how filamentary and Swiss cheesy the universe is, Aldering said. Well, that's all the information we have for you today. Don't forget to give us a thumbs up if you enjoyed today's episode, subscribe if you haven't already, and hit that like bell so you never miss out on future episodes. And be sure to tell us what you think about today's content. Everyone's support motivates us to continue delivering quality content and to always improve. And as always, thanks for watching, and we'll see you next time.